Section 5.4, indefinite and definite integrals. So an indefinite integral would mean something like this. You have this question. What is the antiderivative of x squared? So you can add 1 to the exponent, that's going to be a 3, and then divide by 3. So the antiderivative is x cubed over 3, and then there would be a plus c. That is an indefinite integral. A definite integral would mean integrate from 1 to 2 the function x squared. So you have a definite starting point and a definite ending point. And so for this one, it would be x cubed over 3 is the antiderivative. But for this, we don't have a plus c, because this is saying find the area under the curve of x squared as you go from 1 to 2. So what we get out is area, or in other words, a definite answer. So evaluate this from 1 to 2, which means we substitute the 2 first. That's going to be 2 cubed over 3 minus 1 cubed over 3, which is 8/3 minus 1/3, so that's going to be 7/3. Now there's one other idea in this section before we go on and do several practice problems, and that is the idea of net change. So net change would be, let's say you've got a function like this. It goes something like this. The area down here is counted as negative because the y values are negative. So let's say that this part is a positive 3 area, and this one is a negative 2 area, and this one is a positive 4 area. Then the net change is going to be a 3 minus a 2 plus a 4. Sort of like with a business, 1 month they can make $3,000, next month lose $2,000, and then the next month they earn $4,000, and in total, how much did they make? So let's see, that would be 7 minus 2, so that's a positive 5. Now, if it said find the area between the function and the x-axis, then you'd need to change this one to a positive in order to account for all the area. But if it says net change, then you would just integrate from the beginning to the end. Some positives and some negatives will cancel each other out. In the end, this one ended up to be positive. So those are the main ideas of this section, and now it's time to practice. And then for some examples to practice with, example number 1, what is the integral of secant of x times tangent of x? So then I think about derivatives that I know. The derivative of tangent is secant squared. No, that's not secant squared. The derivative of secant is secant times tangent. Aha, that's it. So that means that the antiderivative of secant times tangent is secant of x. And then put a plus c. Now the good thing with antiderivatives is you could always check your answer. So take your answer and take the derivative. The derivative of secant is secant times tangent. The derivative of a constant is 0, which means this one is perfect. Then for an example that's a little more challenging, how about the integral of sine squared? So then you could think about derivatives that we've done throughout the semester, and no matter how long you think, you're not going to think of one. So we now need to use some type of trig identity. And the trig identity that we need is that sine squared is equal to 1 minus cosine of 2x over 2. This is extremely important because you're going to end up integrating sine squared quite often, and this is the only way to do it. So you need to know that formula. Likewise, there's one for cosine squared. And the good thing is it's almost exactly the same. Just change this minus to a plus. So anytime you run across integrate cosine squared, you need this identity. And for sine squared, you need this identity. Now with that identity, since there's a constant 1/2 right here, I'm going to factor out that 1/2. And then what it leaves is 1 minus cosine of 2x. And then find the antiderivative here. So the 1/2 will stay on the outside. And then the antiderivative of 1, that's going to be x. Now, what's the antiderivative of cosine? Well, since the derivative of a sine is cosine, that means it's going to be sine of 2x. Now I need to decide, do I leave the negative there? Well, the derivative of sine is just cosine, so if I just leave this here, that will give me the cosine, and I need the negative to be right there. Then there's one other thing with this one. If you go to check your answer, the derivative of sine is cosine, the 2x will stay there, then there's going to be the chain rule. So if you take the derivative, you would also have to do the chain rule, and you'd have to multiply by 2. Since this does not have a multiplication by 2, I need to get rid of the 2 that would come from the chain rule. In other words, we need to divide by 2 right here. Then we're done with the integrating, so put a plus c. And you could either leave it like that, or you could go ahead and distribute the 1/2, so it'd be 1/2 x minus sine 2x over 4 plus c. Then for example number 3, how about integrate of 5x plus 6 times a 2x minus 3. Well, this is a product, and we have not covered the product rule for integrating quite yet. So what we need to do is use algebra and go ahead and multiply this out, and then integrate each term. So there's going to be 5x times 2x, that's 10x squared. For the middle term, there would be a 12x minus a 15x. That's going to be minus 3x. And for the last term, there's 6 times negative 3, so that's negative 18. And then find the antiderivative term by term. So this one will become x to the 3 over 3, and the 10 just stays there. This one's exponent is a 1, so that's going to be x squared over 2, and the negative 3 just stays there. And for the negative 18, its antiderivative is negative 18x. And now that we're done, put the plus c. Then, example number 4. Integrate, and this one will be a definite integral from 1 to 4 x minus 1 over the square root of x. Well, this one is a quotient, and we do not have a quotient rule for integrating, which means we need to use algebra. So rewrite this one. When there's one thing in the denominator and more than one thing in the numerator, you can break that up. This one can be broken up into two fractions, one that says x over the square root of x minus 1 over the square root of x. And then I can simplify further. This one's exponent is a 1, and then this is a half, so 1 minus a half is a half. And then this second one, I'm going to rewrite that as x to the negative 1/2. And then Add 1 to the exponent, so that's going to be 3/2, and divide by 3/2. Add 1 to the exponent, that's going to be 1/2, and then divide by 1/2. And of course, when you divide by a fraction, that means invert and multiply. So it'll be 2/3 x is to the 3/2. With this one, invert and multiply, so multiply by 2, and then it's going to be x to the 1/2. And all of this gets evaluated from 1 to 4. So that will be 2/3, and then 4 is to the 3/2, minus 2, and then 4 is to the 1/2 power, minus, when you substitute a 1, this is just going to be 1 raised to a power, so it's going to be 2/3 times 1. So 2/3, and then this one would just be -2 times 1, so -2. And then, can I do this without a calculator? So this means square root. The square root of 4 is 2. You cube that as 8. And then times 2 means this is 16/3. This is going to be the square root of 4 is 2, and times that, so that's minus a 4. And then this would be minus 2/3, and then distribute the negative, and this becomes a positive 2. So combining the thirds, that's going to be 14/3, and then minus 2. And then 2 is actually 6/3. So finally, the answer is 8/3. So that one is a definite integral, so there is no plus c. All right, now for a small application. Example number 5. Suppose you know the velocity function of a baseball. So the velocity of a baseball thrown into the air, I was just going to take a shortcut. Instead of saying thrown into the air, I was going to say throw it up, but throwing up a baseball sounds very painful. So instead, throw it into the air. Is given by velocity equals -32t plus 50. So then, what if you integrate that from 0 to 1? First of all, what's the answer? Second of all, what does it mean for the baseball? Is this going to tell us how much the baseball cost? I don't think so. Well, let's see. What we're doing is integrating velocity. So remember, if you have a function equals the distance, then its derivative equals the velocity. Previous in the semester, we would go from here to here. Well, now we are given the velocity, and if you integrate it, you're going backwards and finding the distance. So what we're going to find is the distance that it traveled over the first second. So integrating this one, its exponent right now is a 1. So when you add 1, that's going to be 2, and then divide by 2. Or in other words, this is going to be -16t squared plus 50 times t, and then evaluate that from 0 to 1. So when you substitute the 1, that's going to be -16 and then 1 squared plus 50 times 1. And when you substitute 0, it contributes nothing to the problem. And so this is 50 minus 16, that is 34 feet. Traveled over the first second. So 0 is the instant that it leaves the person's hand, and then 1 second later, it would be 34 feet in the air. This is also called the displacement. So displace is to change it from its place. So the baseball was here at the beginning, and then it would be 34 feet up in the air, so it got displaced 34 feet. Then, example number 6. So this function is the rate at which water is leaking out of a storage tank. And this is in gallons per hour. So this is a situation where there's this ginormous tank of water, and perhaps there's a little hole in it. And this, as time goes on, is going to get bigger and bigger and bigger. So in other words, if they don't take care of the problem, they're going to end up losing a lot of water. So then find and interpret. So in other words, like the last one, actually do the integral and explain what it means. If you integrate from 0 to 2, this function. So this is very much like the last question because you're given the rate. In other words, you're given the derivative. And if you integrate it, then it's not the rate anymore, but it's the amount of water. So this is going to be the total amount of water that they lose over the first 2 hours. Now to find out how much that is. So the antiderivative here is going to be t cubed over 3, with the 5 just sitting there. The antiderivative of 1 is going to be just t, and then evaluate from 0 to 2. So that will be 5, and then 2 gets cubed over 3, plus 2. And God love the 0. Cuts down on the work. Plug in 0 gives us nothing. So this is going to be an 8, and times 5 is 40. So 40 thirds plus 2. And since this is a word problem, I want to give a decimal answer. 40 divided by 3 plus 2. So then if they get to it right away, they're only going to lose 15 1/3 gallons. So 15 1/3 gallons leaked out over the first 2 hours. All right, see you next section.